Good afternoon, ladies and gentlemen, and thank you for making your time available tonight to witness and be part of the fourth General Aviation Accident Reduction Seminar. The previous three seminars have been a huge success, and they all intend to do exactly the same thing. That is to eliminate, alternatively reduce the level of accidents in the general aviation space. So I can promise you that your time here tonight, the 2 hours that you will be spending with us tonight, will be valuable if you're an aviator. And if you're not an aviator, you're also most welcome to join, because there are some substantial lessons which will be emanating out of tonight's event. So the program for tonight is we will have 5 presentations. The first will deal with the overview of the General Aviation Accident Reduction Seminars, and we have another 4 presentations thereafter. We will have a question and answer segment, which will be for the last 3 presentations. So for all of you who have joined us on Zoom, please feel free to ask your questions for the last 3 presentations, and we will get as many of them answered as we can possibly tonight. The event runs for 2 hours, and I hope to have you all out of here at 8 p.m. So without any further delay, let me introduce our next presentation, or rather our first presentation, and this gives us a bit of an overview on the gas as well as the GARs, and this is presented by Mr. Neil de Lange.
Good evening, everybody, and welcome to this edition of the General Aviation Accident Reduction Seminars. Aviation in particular, and general aviation specifically, is inherently risky. Accidents cannot be completely eliminated. The GA accident rate in South Africa is a reflection of international rates, and we are no less and no more safe than the rest of the world. Our strategy is a long-term initiative designed to drive improved safety through the increased activity, legislative development, education, and awareness. When we look at general aviation, so as to separate it from commercial air transport services, for the purposes of our seminars and for the purpose of reducing accidents, we look at the broader context and the broader definition of general aviation. And this includes flight training, aerial work, corporate aviation, and private and recreational aviation. So general aviation, not necessarily limited only to private aviation. On the other side, scheduled services, obviously, these would include charter flights, on-demand flights, passenger services, and the likes of cargo. In order for us to reduce the number of accidents in general aviation, we had to consider this as a national regional imperative, and this is an organization-wide strategy. So to achieve the reduction in the number of accidents, it's vital that we identify and address the underlying precipitating factors that often leads to accidents. Then we have to have a multifaceted and multidisciplinary approach to address these factors. Have stakeholders from the industry participate in a coordinated effort in focus groups in order for us to address these various factors, and have a sustained inclusive initiatives implemented to these initiatives to put them into effect. These focus groups that the industry has participated in and that we continue to work at looks at safety outreach, and you may have seen the Skywatch editions. I think we're now in our 14th edition. Education guidance material that is developed specifically for the purpose of accident reduction seminars, medical supports to dames and pilots alike, developmental initiatives within GA that will also address these safety factors. Obviously, there's the issue of RPAS and UAVs and drones in the GA space. And trend monitoring and research is something that we continuously embark on to measure the successful implementation of these initiatives. Here is a summary of focus group activities. And you can see in the center section of the slide there, these work groups are coordinated by a central management entity within the authority. So why general aviation accident reduction seminars? The idea is that we have repeatable, effective, and measurable seminars where the outcomes can be measured for the effective implementation. And then the question often is, why is this necessary? So standard training and syllabi is inadequate in the sense that it teaches you stick and rudder skills, it teaches you how to fly the aircraft, but doesn't always address these underlying precipitating factors. No specific accident avoidance training is conducted during ab initio training. So obviously this is part of the continuous education and training that we would like all pilots to become aware of and to undergo. There's no specific accident avoidance material in the ab initio training, and we are supplementing the training by this additional educational guidance. There's no specific accident avoidance trainers available, and for that purpose we are reaching out to our instructors to become more involved in this program to impart the specific knowledge. And there's also no specific accident avoidance testing. So obviously once you've undergone the training and once you've undergone some of these seminars, you would be able to identify those factors. So without any further ado, let me introduce you to the program lineup for tonight. First we have Soomesh, who's going to speak to us about the accident statistics. Now, Soomesh Maharaj is manager with AIID and will put us into context of where we stand with accidents and incidents. Theo Odendaal will be talking to the fixed wing technical guidance material. Bongi Mtlokwa will be talking to safety culture, and new element that we are looking at in terms of SMS and SSP, but also equally applicable to the general aviation environment and specifically the private aviation environment. And then Gove will talk to us about the helicopter technical guidance material. Now, we will also have an opportunity to ask questions during the course after these presentations, but let me hand back over to Subhash and let's get the ball rolling. Enjoy the evening, enjoy it, and thank you for joining us.
Thank you, Mr. Neil de Lange. I'm sure after watching that presentation, we all have a very good understanding of this initiative, the GARS, as well as its very noble expectations as a product. So next up, we have Mr. Soomesh Maharaj. He'll be talking to us about why all of this activity is so important in 2024. And specifically, I'm referring to the aircraft accident rate, and we're going to unpack that right now with Mr. Soomesh Maharaj.
Good evening, everyone. My name is Soomesh Maharaj. I'm from the Accident Incident Department. And this evening, I'm going to discuss with you some accident statistics as we go along. Right, so our points of discussion for this evening would be just the outlook on what the aviation occurrences are. We'll go into some of the accident numbers and break that down into the fatal accidents per category. We'd look at some of these phases of flight where these accidents happen, especially the fatal ones. And then we'll break down the causal factors of what causes these accidents. And what we'll do is a bit of a dive into some of it before we conclude with the safety recommendations. All right, so getting into the numbers, just to have a look at the total occurrences that we have received for the last 3 financial years. You can see that for 2022-2023 financial year, 291 occurrences. And here we're just looking at the accidents, serious incidents, the air proxies, and some of the confidential aviation hazard reports that come through the reporting system that we manage at AIID. For the current year, we've just looked at the first quarter, which is April to June. And we've recorded thus far 33 accidents, 9 serious incidents, 33 airprox events, and 29 cars events. That gives us a total of about 104 accident occurrences recorded. Based on the current flying hours and just the estimate that we have there, we do see that it is a decrease of about 9% per 10,000 flying hours flown. All right, so just having a look at the accident numbers for the last 5-year period or so since 2018. What we've done is we've given a gauge of where we were pre-COVID, during the COVID, and then post-COVID. So if you look at the red bar on your left-hand side, you would see that the numbers are just below the 100, and then obviously a spike as we came out of COVID, where we recorded 147 accidents. In the last few financial years, those accident numbers have come down since the COVID period, but they seem to have stagnated around the 110, 115 number. And if you just look at where we are currently, when we're looking at just the first quarter number, we're most likely going to get to about the same 110 to 120 accidents recorded for this current financial year. Taking the fatal accidents into consideration, what we've done with this slide here is we've broken down the fatal accidents per operational category. So what you'd look at is that 48% of fatalities that we record is in non-type certified aircraft environment, followed by 22% in the general aviation operating environment, where then the balance is attributed to training organizations and agricultural operations. And then taking that stat further and breaking it down into the phases of flight, what we see here is that when we look at the landing phase of flight, we see that of the category of operation where we look at the non-type certified aircraft, we see 67% of fatal accidents are in the landing phase, and the other 33% is basically in flight. When we look at training organizations, we see again a large number of the accidents which are fatal happen in flight and during the landing phases, whereas when we just take a look at the agricultural operations, most of those fatal accidents actually are in flight. Moving on to what causes these aircraft accidents, and what we've done is we've just looked at the top 10 causal factors that we have recorded over the past 4 financial years at AID. And one thing that shines out a lot there is just by sheer number, is the pilot and the flight crew contributory to the causal factors of accidents, then followed by mechanical engineering and power plant, with the third one being collision and structural damages, if you just had to look at it. What we're going to do is break down these causal factors in the next set of slides. When we're looking at the causal factors and we break it down per financial year, what we want to do is get a picture of what the trend is in those top 10 causal factors that we look at. So when we go and we look at the flight crew, pilot operations, what we're seeing as a trend is that over the last few financial years, these numbers have been increasing, which means more accidents are being attributed to the pilot and the flight crew. When we go out and we look at the engineering power plants, we see that that is a decreasing trend, where you've gone from the 2021-22 cycle from 29 to 26 the following year, and where we had 14 of those causal factors in the last financial year attributed to mechanical failures. So this slide just represents a breakdown of where we see the causal factors. What we will do is we'll unpack this in the following slides. All right, so unpacking these causal factors, and just specifically to aircraft operating in the general aviation sphere, again, over the past 5 years, the theme seems to be recurring, where you can see that the flight crew contribution is still one of the highest throughout the years, with the most obviously being recorded in the 21-22 period. That's where we've recorded the 147 aircraft accidents. And when we look at the non-type certified aircraft, again for the same period, What you see here represented in the green bars and the blue bars is again that variance and the change that's happening just for the specific sector of NTCA aircraft. Again, the total contribution of flight crew is an increasing one. All right, so when we talk about the causal factors of flight crew and pilots, what are we talking about? What is it that they contribute in terms of accident causation? And what you'll see here is that 21% is loss of directional control on the ground during the takeoff or landing phase, with majority of that being on the landing phase. The other attributions are poor airmanship technique, unstable approaches, and heavy or hard landing. So again, when we look at accident causation and we look at what the causes are, and you take the subgroup of flight crew and pilots, what you see here is that at which phase of flight, which is again the landing phase of flight, and what leads to these accidents is what is known as airmanship and aircraft handling. When we break down the mechanical engineering factors and power plant factors, again, what we see highly here is fuel starvation, fuel exhaustion, and then obviously fuel contamination on the other side, and the others related to mechanical issues related to engine failure or power loss, etc. Importantly, to take away from this slide here is that fuel starvation events or fuel exhaustion events are what could be considered avoidable accidents. It is something that, if managed properly by the flight crew, by the maintenance crew, could be totally avoided. And this would then also lower the number of accidents that we see in the general aviation sphere. When we have a look at the factors that lead to collisions and the subcausal factor, we can see wire strikes or collision with the ground attributing to most of it, which is about 37%. Again, this we don't see as much in the general aviation and the NTCA environment. This is most likely recorded from the agricultural operations, and this is also due to the nature of the functions performed in terms of agricultural operations. Again, here, a collaborative effort needs to be made in order to scan and identify these hazards that exist, where we can then lower the number of accidents with regards to collisions. We did also record 2 mid-air collisions in the past 3 financial years, and again, these are, I think, avoidable accidents. So what is it we do at AIID that helps reduce these accidents and prevent reoccurrence? Well, the mechanism that we use is to make safety recommendations in our final reports and through our investigation process. This is achieved by sending safety recommendations to specific organizations in order for them to be able to implement these recommendations to improve aviation safety. What we've seen is that over the period of the last 3 or 4 financial years, we've issued a total of 76 safety recommendations, most of which go to the Civil Aviation Authority, some to the manufacturer, and others to the ATC or ATOs and airports. And this is simply because these organizations, being tasked with oversight functions, have the ability to influence the outcomes of accidents in the future. A key takeaway from this slide is that 89% of the safety recommendations issued by AIID overall are addressed and closed with effective implementation. And that is a good way for us to monitor these accidents. But as said in the previous slides, most of these accidents, I believe, could be avoided and are avoidable accidents, and it comes with just a little bit of practice.
Welcome back, and thank you, Mr. Soomesh Maharaj. So, to all the audience present tonight, you can clearly see the stats speak for themselves. These are real-world stats. These are stats within South Africa, South African aircraft, and these are stats of fatalities, of injuries, of aircraft damage, and of many incidents. So the question is, can these be reduced? And the answer is an obvious yes. So we're glad you're still part of this discussion. This is now the first presentation where you can ask questions. Please keep your questions on Zoom during the presentation and even post the presentation. And once the presentation has been concluded, I will then ask these questions to Mr. Theo Odendaal. So I've mentioned his name. Mr. Theo Odendaal will be speaking to us about density overloading and density altitude and overloading. Mr. Theo Odendaal.
Now, you might or might not be excited to know that I brought us a few toys along. I'm going to show them to you. And what I am showing, you might not know this, you probably won't know this. I have aspirations to be a rock climber. I never said I'm a good rock climber. In any event, so the first device I'm going to show you, is this little device that's got a trigger system and two lobes that pull in. This is called a cam. Now, this is a device that's lodged into cracks in rock during climbing to protect yourself. You hook the rope into this, and that stops a fall. This specific one probably saved my life during a pretty bad fall. I've got another little one to show you. This is a big eye. This is a number 6 cam. They are rated in numbers. So this was incidentally given to me by a friend that recently immigrated. And what's interesting, these devices, various types of devices, have load factor ratings, strength ratings. This one specifically has got a 12 kilonewton rating. In other words, in the region of 1.2 tons with a static load. I've got another little interesting device. This one's called a screw gate carabiner. There's no chance that you'll be able to see this, but this screw gate with the little gate closed, locked, has got a 24 kilonewton rating. That's 2.4 tons static. What's interesting about these little devices is that if you open the gate and you load it like this, that drops by 70%. And the last one piece of toy I'm going to show you tonight is this little piece of webbing. Right, so this piece of yarn also has a rating. This is called a sling. You use it you attach it to these other things and all these other devices. This one also has a rating, and this little piece of webbing has a rating of 22 kilonewtons. So that's 2.2 tons static. Now you might ask yourself, what on earth is the reason for showing you this? I'm going to, well, you might actually ask yourself, what's the purpose of this? You know, what can I actually do with these things? And I thought you might find it interesting that I'll show you a little video, which is fascinating page which I follow. On various social media platforms, how not to. This particular video is called This Seems Sharp. And this group of people, for whatever purpose, do strength and brake testing of extreme sport equipment. So we're going to play that video for you. Don't worry, not the whole one. We're going to play you 3 minutes of that. And our esteemed colleagues that are assisting us today are going to play this right now.
No way! It's over 20!
Missed my cue there,
I
boss.
didn't know I was going to give you a cue until I gave it to you. We're going to test a lot of girth hitches today. We're going to do it with Dyneema slings.
Nylon.
And we're going to do it on hangers. We're going to do it on round stock, like a climbing ring or a carabiner. We're also going to test girth hitched master points. John Godino from Alpine Savvy from Instagram and alpinesavvy.com. One of the most popular things I see on your page is people talking about girth hitches. What is the number one concern that people seem to have when you bring up girth hitching this to a hanger or girth hitch master points or anything?
Seems to be that it dangerously weakens the material to some catastrophic potential level.
And what do you think?
I think generally it doesn't, because we're starting out with something that's really, really strong in the first place. But let's hit it and see what happens and see if our assumptions are correct.
I'm trying to read all the future comments before I see them.
Good luck with that one.
Let's start by putting these slings directly on a hanger. Oh, that was higher than I thought. I'd like to just point out your Dyneema sling, you're all worried about it girth hitched on there like that? Look what it does to the hanger. It was lower.
Like
That's too low to be good. Consistently not good.
You can see that one has a tiny bit of damage there. And it was creased, obviously. I just wonder how much dressing or undressing it or an inadvertent twist in here. And this one you can see is obviously really messed up in a few different places.
Look at how it's damaged before. Like,
It's quite comparable to that one.
Yeah, and then some of the other ones are more just pop, where it just failed in one spot. So
yeah. But the numbers were very consistent.
on the Dyneema, certainly, yeah. And it is pretty consistent on the nylon, too.
If you erased nylon and Dyneema and said which one was nylon and Dyneema, I would have guessed 100% the higher number was nylon. What's next, John?
Well, we're going to check out girth hitch with the Dyneema sling on a rounded surface here. Note this carabiner is totally round bar stock, not I-beam style, which might offer a little more friction.
The bend radius is less sharp. This, in theory, should give us more strength. 17.62.
There you go.
You know, get a little deformed there, like inside the...
Looks really damaged right here, though.
Yeah, certainly where it broke.
No way! It's over 20!
Back to me. Fortunately, you can't throw me with rotten tomatoes. Why on earth is this inspector showing us videos of people doing braking stuff, braking equipment? So it's interesting what you might have seen in the video is that the supposed 22 kilonewtons is affected by things like knots. There was even between an 8 and 9 kilonewtons. So what can I do with this thing? It's made to do certain things. Someone designed it to do certain things. When you do rock climbing, your life depends on that, and you're acutely aware. But when we come to aviation, it changes. Just close the door and things will happen. Everything's fine, Jan Brandt says. And folks, without making any assumptions or predictions or accusations, it happens. What you see in front of you is the wreckage of Juliet Zulu Foxtrot, a Piper Lance 2008. Folks, on the right-hand side, that's pretty much what was left of it. And this leads to what I'm going to be telling you today. Just a little bit of a new perspective maybe on density altitude, high density altitude, and overloading. So in a nutshell, these 6 points are what I'll be discussing with you. There's a 7th one which I'll be closing with. So first of all, we're going to look at a bizarre topic which you might or might not have thought about. What are the duties of the pilot in command of a flight? So a few thoughts on air density and atmospheric density, effects of density altitude, very simple density altitude calculation, and some factors relating to weight and balance and loading. So think back about the example, the climbing equipment that's certified. It's made by someone according to certain standards, and it's supposed to do that job, and you can have surety that it can do that job. And aircraft are designed to do exactly the same way. That aircraft, someone applies for a type certificate for that aircraft. The aircraft is then, the design is approved, the aircraft is built to be able to do that. And it's then, the type certificate becomes a kind of a contract between the approving authority and the manufacturer. So that's aircraft design. Now, Part 21 of the Civil Aviation Regulations deals with certification. We'll look at a few slides related to that. We're going to look at Chapter 14 of the American Regulations, talk about performance and controllability and some POH limitations. So first of all, Part 21, Civil Aviation Regulations, that's the certification part. You might not have looked at that yet, that's all right. Now, this, what you see in front of you is Technical Standard 21.02.3, Airworthiness Design Standards. And what you see there is this absolute hidden gem in the regulations, which says for type certificate which national regulations need to be complied with. And if you go down to 1.3, you'll see aeroplanes, normal utility, acrobatic, commuter categories. We, the South African CAA, requires compliance with the CFR 23. Now, a word on the American regulations and how they're structured. They look a little bit different from what we do. So, the old FARs, Federal Aviation Regulations, the titles have changed. They are now the Code of Federal Regulations. Title 14 deals with aeronautic and space. Chapter 1, Subchapter C, deals with aircraft. And that brings us to 14 CFR 23. Now, this sounds like total Latin. Folks, that is basically what it looks like. Part 23 deals with airworthiness standards, normal category aeroplanes. Zooming in a little bit closer, that's what it looks like. And you might still be trying to figure out what this is about. The Piper Lance and quite possibly the aircraft you fly are certified according to these standards. This is the agreement between the FAA and the manufacturer, which entails how this aircraft is designed and built. So how does that look like practically? And you'll see the applicability and definitions, what it says. I'm going to read this to you as a courtesy. This part prescribes airworthiness standards for the issuance of type certificates and changes to those certificates for airplanes in the normal category. You'll see there at the very bottom, 4 levels of certification. That's not the point. What is the point? Well, this is how this aircraft is built, designed, approved. Weight and center of gravity, for example, you'll see this falls under the performance section. And I'd like to focus your attention on paragraph A there. The applicant must determine limits for weights and centers of gravity that provide for the safe operation of the airplane. What that means, the certification limits determine what is safe for this aircraft to do. Outside of that is not guaranteed safe, and you would have to be pretty sure of yourself to go beyond what the manufacturer thought was safe. The second aspect, very interesting, controllability. Once again, paragraph A, the airplane must be controllable and maneuverable without requiring exceptional piloting skill, alertness or strength within the operating envelope. And A1 says, at all loading conditions for which certification is requested. Outside of the certification scope, there is no guaranteed safety, no safety margin, and in fact, it's a reasonable assumption that outside of those limits, the aircraft might be inherently unsafe to fly. Interesting, subpart C structures. And once again, in this case, I'll show you an example of a type certificate. The manufacturer, who is the applicant, must determine the structural design envelope, which describes the range and limits of airplane design and operational parameters for which the applicant will show compliance with the requirements of the subpart. What that means, folks, is that inside of that safety framework is the aircraft is safe to fly. and you'll see where we're getting with that. This is an example of a type certificate. The Americans call it a TCDS, type certificate data sheet. This is for the omniscient Cessna 170. It's got a number 3A12, and you'll find everything, the whole approval scope in this document. Those restrictions, limitations are then put into the POH, and this is the Piper Lance example of which I showed you earlier, the aircraft that had an accident. And Section 2 of every POH manufactured in the US contains the limitations. And I'd like to show you just the center of gravity limits are there, maneuver limits are there, and so forth. Now, why is this important? Well, let's have a look at that. Regulation 9127. What are the duties of the pilot in command regarding flight preparation? Well, the POC may not commence a flight unless he is satisfied, or she, that the mass of the aircraft does not exceed the maximum certificated mass, and that the center of gravity is within limits in this AFM. So you do need to be acutely familiar with the requirements and the limitations in the POH. And it doesn't stop with flight preparation. Flight operations, 9128, I'm not going to read it all to you, but it's the duty of the pilot in command to operate the aircraft according to the instructions and limitations. Now that's a mouthful of legalese. I'll move on from that. That's a little bit of background, but the idea was to paint a picture of exactly how this flying machine is actually built, what it's capable of doing, and why you have to operate it within those approved limitations. Right, so keep in mind we're talking about density, altitude, and aircraft operation loading. So very simple question, what is density? Well, good question, simple answer depending on where you're looking at. On the left-hand side of your screen, you'll see two little canisters. One's got lower pressure, other one higher pressure. And that's a very nice depiction of higher air density with higher pressure. Lots of little dots in a right-hand canister. Also, hot air has a higher kinetic, the molecules have higher kinetic energy, and these things are spaced out over a bigger area, which is why cold air typically has a higher pressure. So what would the effect of air density be? Well, pretty much it affects the performance of the whole aircraft. It affects the wings, the control surfaces, the engine, how much oxygen is ingested into the engine. And there's a very intuitive way of calculating that or getting a feel for what's going on, and that's really what density altitude is about. Theoretically, per definition, density altitude is pressure altitude corrected for temperature. And of course, the higher the density altitude, the lower the aircraft performance, because that's where in the atmosphere where the pressure would be lower and the density lower. Very practically very great little description, a little bit simplistic, but simply speaking, low altitude operations dramatically affect the aircraft performance. In this example, a substantially reduced takeoff ground roll for an aircraft taking off as opposed to one that's at higher altitude. So that's now the elementary theory. The practicalities are that the atmosphere is in flux. It changes. These things change continuously. I'm going to show you 2 or 3 images that explain just how much fluidity and change is in atmospheric conditions. So there are very simple rudimentary calculations for pressure lapse rates and temperature lapse rates, but the reality is not quite like that. So this is a well-known typical graph showing just how temperature lapses with altitude, that's on the left-hand side of the graph, and how pressure decreases with increasing altitude. So that's the theoretical model. Many of the calculations that we do rely on assumptions, to make life easier for pilots. Many of them are not realistic, and typically this shows you how unrealistic some of these measurements are. So 2 images, one from Dodge City, both from Dodge City. The first one just shows some data from balloon soundings. The point here is that these things are a lot more messy than we often make them out to be. The pressure lapse rate is in the left-hand column. There's height, and you can see the temperature. There's actually a temperature increase, 20.4 degrees, 21.2, big drop to 18.8, and at some point there's an isothermal layer. So the atmosphere doesn't always behave the way we want it to, or that our manual says it should. And a little bit more dramatically, this is also Dodge City. These are actual upper air measurements at Dodge City. 2012, the blue line shows the lapse rates, the temperature lapse rates with height in Northern Hemisphere winter, right? The red one is in summer. And you can see how much those lapse rate differ from the actual authentic, from the theoretical model. On the red line, you can even see there's an inversion at very low altitude. So these things don't always work out the way we want them to do. Having said that, for simplicity's sake, what we would like to do, what we have to do as pilots, is just have some very simple calculations, some rules of thumb. And these are pretty much that there's a temperature decrease with altitude, 2 degrees Celsius per 1,000 feet, a pressure decrease of 1 hectopascal for every 30 feet. And the effect that has on density altitude is that for every degree Celsius that the atmosphere is warmer or colder than ISA, there's 120 feet difference. How would that work in calculation? Well, very simple. Assuming that surface conditions are as you see in front of them, 1023 hectopascal, 5.5 elevation, and outside air temperature 25 degrees Celsius. Well, let's have a look at how to determine the pressure altitude and how to correct for temperature deviation. I just have to make a correction. This, what you see in front of you does not match exactly. The 25 degrees was a typo. That should actually be 18. Nevertheless, first of all, let's check the pressure altitude. We determine that by subtracting standard pressure from the actual QNH. In this case, that's a 10 hectopascal difference. 1 hectopascal, the assumption, as you remember, is 30 feet. 10 hectopascals would give us 300 feet. In other words, the pressure altitude is less than the elevation 5,200, which sounds good, except let's look at the temperature effect. So if we assume that the temperature lapse rate is 2 degrees Celsius per 1,000 feet, 10 degrees Celsius over 5,200, and that brings us to a conclusion that ISA should be 5 degrees Celsius. Is it ISA? No. So there's a 13 degrees Celsius difference from ISA, which gives us approximately 1,600 feet extra, which for this Piper Lance aircraft brings us to a density altitude of almost 6,800 feet. Folks, that is very significant. You might ask yourself, well, what's the POH for? Well, the POH actually has that in, just calls it differently. If you do your takeoff calculations, you do your performance calculations, takeoff and climb, you should be fine. This is an example from the Piper Lance, and it's interesting how with increasing temperature and increasing mass, aircraft mass, how dramatically these things change. A big factor, of course, how these things come together. Having looked at that graph, what's the effect of temperature on indicated airspeed and TAS? Well, pretty much as a reminder, indicated airspeed is not a speed, it's merely a pressure. True airspeed is the speed that the aircraft is actually flying at, and that is important. There's a very big distinction. One could have a very lowish airspeed and a very high true airspeed, and that could lead to runway overruns, takeoff issues, and so forth, as you can see in that right-hand picture. Now, you remember that little popular pilot saying, if the doors can close, the aircraft will fly. Oh yes, have a look at that. There's a limit to what these things can do. I hope that is starting to become clear. So there's a weight and performance issue. There's another issue, and that's the controllability, as you might remember from the FAA. Folks, the controllability refers to whether the aircraft is actually controllable by the pilot, and that is a very important design parameter. Center of gravity too far forward, too far back. The point is not which is better. The point is it should be correct. Now, how does this relate to the GAS program, the GAS seminar series? Why do we want you to know these things? And I've listed a few of these specific and critical cross-field outcomes for you, which is essentially we would like to get our pilots thinking a little bit deeper about the types of accidents, what could the contributing factors be, exercise some better judgment, use this information to make pre-flight and in-flight decisions, address the misconceptions which abound in aviation, and maybe even empower our pilots to be a little bit more resilient against pressures to fly, whether they're self-imposed or externally. Now, you can ask us, what's the point of all this stuff, folks? Where are we going? There's a long spiel, a long speech. And thinking about this whole presentation, how does it tie together? There's so much that we as pilots know, and yet these things continue, they still go on. And what you'll see there in the corner of your screen, folks, threat and error management. You'll see the very interesting graph there, which details the elements of threat and error management. Errors are unavoidable, but we try and avoid them. Threats are part of what we do. Threats have to be managed. If an error happens, let's manage it. If it's not managed well, it leads to an undesired aircraft state. And that is that's the back against the wall aspects that need to be looked at. So 5 kinds of threats that ICAO identifies in its Human Performance Manual. Pretty much intuitive, understandable once we're familiar with them, but they are pretty much the number one. What you can see there is simply, I knew what to do, I just decided not to do it. I deliberately committed an infringement. A procedural error refers to situations where a pilot knows what to do, tries to do it, but makes a mistake. A communication error is simply what it is. And for those of you familiar with language proficiency and radio comms, folks, that's a major in-flight risk. Proficiency errors are errors simply where a pilot it lacks the skills. There's simply a deficient lack of knowledge, skills, and maybe poor attitudes. And lastly, operational decisions error, simply in the heat of moment, errors that were made. Now, very simply, looking at the Piper Lance, there are a couple of factors, and once again, no finger pointing, nothing. High density altitude was a factor there, folks. High density overloading and low performance, and once again, aerodynamically, high density altitude, everything is affected. Engines, airframes, controls, sim propellers, control surfaces. The overloading aspect, folks, has a structural issue, performance issue, and a controllability issue. Now, which leads me to the main point of this discussion. Threats can be overt or latent. In other words, threats can be visible, recognizable, you can be aware of them, they can be hidden in the system. Why do pilots go and, with open eyes, make decisions, take decisions to fly, to do things that they should not be doing? And that really is the million-dollar question. Safety campaigns, awareness, exams, training, and so forth. And I thought that for this presentation, this topic, the most fascinating aspect, the best way of saying it, I thought, is what ICAO says. And the quotes you can see there in front of you is from the Human Factors Manual, the Threat and Area Management section, which basically says, and I thought as a pilot myself, that makes sense. We see these things, we know of them, but we normalize them. We get so used to these aspects, these problems, these threats, these dangers, that we start living with them. We start pushing the boundaries. We allow someone else to push our boundaries. And the whole point of all these things is really for us to think about these things. Whether you absorb everything that's in here or not is not the point. If it triggers some thinking, if it forces you or impels you or motivates you to think slightly different, anticipate some threats, think about what could go wrong, what could I do here, is there anything I'm not aware about? Folks, if that's all you take from this, it's a success. Now, I would like to end you off with this fantastic quote. It's possibly my personal favorite aviation quote from Frank Borman, who was one of the most senior commanders in the American space program in the Gemini series and the early Apollo series, basically saying that the superior pilot uses superior skill to avoid those situations which, my apologies, superior pilot uses superior judgment to avoid those situations which require the use of superior skill. That's it from my side. Thank you for listening to me. Thank you for bearing with me. If you call me, we can talk about climbing, but ideally, let's talk about some aviation. And I'm happy to take some questions from you folks.
Well, thank you, Mr. Theo Odendaal. You certainly brought through to the audience the complexity involved in aircraft design, manufacturing, and even maintenance. It's not just about flying the aircraft. So to the audience, we're now at a point where you can ask questions on Zoom. I will receive these questions here, and I will be able to ask Mr. Odendaal, and he can assist us with some further clarity. Theo, firstly, thank you for your presentation. You went into substantial detail. And I do have a question for you.
Please, thank you.
So you've spoken a lot about rock climbing and the importance of aircraft certification in relation to rock climbing. So in your own mind, why do you think pilots who are watching the event today should know so much about aircraft certification or design? Do you think this is something that substantially could allow them to fly an aircraft safely?
Thank you. It's a very good question. I was hoping that no one asks that question. So there are probably, we can look at it in a couple of ways. The point is that there are so many hidden assumptions for pilots, for example, that they know the flying of an aircraft depends on so many other factors, and there are so many legal requirements that we get unaccustomed to, which we should really be knowing. And eventually, I think there's a strong case to be made for the more we know, the more skilled we are, the more prepared we are. Are we all going to become aircraft designers? Certainly not. I wouldn't do that. Fortunately, there are smart people that do that. But why be minimalistic about knowledge? Why not understand more? Why? I would certainly, from my side, always advocate let's not motivate knowing less. Let's know more. There's no harm in that. And it does open up the fascinating field of these things. These light aircraft, the manual in front says, the PH says, certified in terms of FAR 23. Surely an intelligent pilot would want to ask, well, what is FAR 23? Should one memorize the American regulations? Not necessarily, but those that affect us, yes. I think certainly that would be my mediocre answer to a good question.
Sure, and what you highlight as well in all that you've said today is that the limitations of an aircraft certainly must be observed.
Exactly. And the pilot has a legal duty to observe those limitations, irrespective of a common sense duty to just be safe in the interests of self-preservation, one could argue.
Yeah. So we often find pilots, those that find themselves in positions where they've gained a lot of experience on a particular type of aircraft, feeling they know the aircraft very well, and they also feel that this aircraft can perform a lot better or take a lot much, probably a whole lot more load than it has been certified for. What would you say in response to someone who believes that?
Well, I would. That's also one of those tricky questions, and it's an awesome question. I think, and I found my own presentation also challenged me in a few aspects. And what is interesting is that the aircraft is certified, designed, and manufactured and maintained for a certain envelope. That's really what it's supposed to do. And one might push the limits of that envelope, but once you start hitting the extremes and the holes in the Swiss cheese start lining up, you could inadvertently, out of nowhere, have the right combination of aspects that simply make the aircraft uncontrollable. It's not. There's a limit to its capability, there's a limit to its maneuvers, and if a lot of things add up in the wrong direction, I think you have a very surprised pilot, and the aircraft behaving, doing what it wants to.
Excellent. Thank you, Theo. So please do continue to send your questions through to us. So we've got an additional 2 questions.
Oh, there's some easy questions as well,
They look about as complex as your presentation. So I'm sure you're more than up to the task. And the second question on this is a density altitude calculation. It does take time. It does take a bit of skill. Do you think it's necessary for a pilot to do this every time they take flight, if they're flying from the same airfield? Why?
Yeah, that's a good question that flight instructors have to answer to their students every time. I can give my personal opinion. There's no legal requirement to directly calculate the density altitude. It's implicit in the other calculations. What it is, personally I've found, is a very useful, intuitive way of seeing the effect of pressure and temperature on what's going to happen today. Making a long calculation, and the ground roll is going to be 800 feet instead of 670 or whatever numbers, seems a little bit abstract. If you calculate the density altitude, my takeoff altitude effectively is not 5,000 foot, but 8,500. That's an eye-opener. So I found that maybe one could argue that it's a tool, a calculation or a preemptive or the threat management tool. That's what I would reason. It's a useful, handy, intuitive tool.
So Theo, you spoke now about threat and error management tool. And our final question for you this evening is, do you think this threat and error management also applies to a private pilot, not just commercial or airline pilots, and even to a national pilot?
Well, risks and threats and accidents apply to all pilots, and so threat and error management should also apply to all pilots. And I think instead of, as pilots, what we often try and do, and as all kinds of aviation professionals, we tend to lean towards the legal side, and must I do threat and error management? And actually there's a whole world that opens up if we look at it as a tool, a self-empowering tool. So instead of doing some legal calculation, for compliance purposes, what about taking a deep breath, sitting, what are the risks to this flight today? Are there any? We don't even have to make up risks. As a practical, everyday tool, what threats are there? Have I made any errors? So maybe even in terms of situation analysis, even if it's practical, informal, but some form of decision making, and the preparation and the mental setup for a pilot in that is so valuable. Pilot, it's just one more way of putting the pilot in front of the aircraft. That's maybe one could answer it like that.
Well, thank you, Theo. I'm confident your presentation and also your responses has been most impactful to the attendees. With that being said, that would be our final question and answer for Mr. Theo Odendaal's presentation. Next up is Ms. Bongi Mtlokwa, and she will be talking to us about safety culture. Thereafter, we'll be following up the presentation with a Q&A. Stay tuned.
Good evening, everybody. My name is Bongi Mtlokwa. Welcome to the General Aviation Accident Reduction Seminar. I'm happy to be here today, and I'm looking forward to spending the session with you, where we'll be covering the aviation safety culture, so that we can see what is it that we can do to adopt the right behaviors so that we can be safe, especially when it comes to the entrenching of the aviation safety culture throughout all sectors of aviation, not leaving out the general aviation, because as we know, the accidents, as they have been presented, they show that some of the accidents could be prevented had we adopted the right behavior. So I'm happy to be here, looking forward to spending the session with you. So the purpose of my presentation today, I'll be covering three main areas. The first area that I'll be covering, obviously, is the definition of safety culture. What is safety culture all about? And what are the values that we need to adopt when it comes to the safety culture? And also, I'll be covering the initiatives that we are doing as the CAA in terms of entrenching a positive safety culture. And also, I'll be covering what is it that you can do as an individual and also as organizations to entrench a positive safety culture. So while I go through the presentation, I want us to ponder in terms of what is it that you can do personally in terms of adopting the values of a positive safety culture. I know in most instances when we speak about positive safety culture, we usually speak about it in an organizational context, but in this instance, I want each and every one of us, as we present the values of a positive safety culture, just think, how does this impact me as an individual, and how can I adopt the values and live the values of a positive safety culture? What is safety culture really? People have different understandings, different definitions of a safety culture, but according to ICAO Doc 9859, the safety culture is described as how people behave in relation to safety. Not only people, but also organizations. How do we behave when we are faced with instances whereby we have to make decisions in a safe way? So it covers different aspects. It can cover the procedures that we have in terms of supporting a positive safety culture. It covers an individual in terms of the behaviors that we have, and it also is influenced by other cultures, for an example, a personal culture or an organizational culture as well. Okay, so when it comes to the foundation of a positive safety culture, mostly it is based on the processes, the procedures, and the regulations that we would have in our different environments. What I want to focus on is that in as much as we have the regulations, we have the procedures, we have the processes, however, safety improvements demands our attitudes, our mindsets, and our behaviors. Yes, regulation is the base, but how do we behave as individuals when we're faced with a safety situation? So the emphasis here is that in as much as we can have regulations, regulations are not always watching what we do, but as humans, as individuals, how our attitude is towards safety, how we behave when we're faced with safety situations or instances whereby we have to make decisions. That is what plays a more important role. As you would describe safety culture or just culture in terms of what is it that we do when no one is watching? When CAA is not there, how do I behave? What is my attitude? So the fundamentals of safety culture is those 6 elements that you see in my presentation in terms of the sharing of information, the environment whereby there is trust, environment whereby we are aware of the safety issues. But most importantly, it's about us. How do I behave when I'm faced with different instances whereby no one is watching? So as I've just mentioned, there are 3 key determinants when it comes to a positive safety culture or a culture in general. We have people in terms of in the organizational context or the individuals. Then we have processes and procedures, because it makes no sense to say we have a safety culture, we have a just culture, if it's not supported by the right framework in terms of the processes and procedures. So all these 3 ingredients, which is people in terms of our values, our behaviors, also the processes and procedures that we have in place, all these 3 ingredients, they play a major foundation when it comes to a positive safety culture. So in the organizational context, when we talk of a positive safety culture, we talk about it in the context of the 6 safety culture values that we want organizations to live by. So these values, as I've mentioned, that in the organizational context, at the same time, I want each and every one of us as individuals, especially in the general aviation context, I want you to ponder in terms of how can I, as an individual, live the safety culture values. So what are they described as? One important one that I would like to start with is commitment. Commitment that safety is the key consideration in the organization when it comes to decision making, because we know that in some instances there are conflicting priorities. So we want to see that management and also employees have commitment, or they are committed when it comes to safety. And we want instances whereby information is shared throughout the organization. How do we do this? Through reporting, which is a key factor when it comes to safety management. So we want information to be shared throughout the organization. We want people to report so that people are aware. It comes to the awareness, are aware in terms of the risk that they face in their operations, so that they can make the right behaviors. And also, right behaviors, how do we behave when we are faced with instances where we have to make safe decisions. So in the next presentations, or in the next slide, I'll go through each and every one of the safety culture values to see what does each value mean, right? What are the key enablers and what are the key disablers when it comes to each culture value. And just to remind you again, as an individual, please ponder as to how can I live each and every one of these safety culture values. So let me start with the first safety culture value, which is commitment, right? Commitment starts from the top. So we want to see that those who are in management or those who are in leadership, their commitment to safety. How do they display commitment, or what are the enablers, or how do we see that people are actually committed to safety? From the management perspective, we want to see them promoting a positive safety culture, not only talking, but actually taking specific actions to promote a positive safety culture. Secondly, we want to see those who are in management or the leaders actually providing the resources that are needed when it comes to the technical staff performing their duties. And also they have to ensure that there are appropriate governance structures in terms of the processes and the procedures that are required so that they can support a positive safety culture. Remember, I've mentioned previously that in as much as you can say you have a positive safety culture, but if you don't have the right processes and procedures to manage your positive safety culture, that's not going to work. Therefore, it is the responsibility of management in terms of providing those governance structures in terms of the processes and procedures to manage a safety culture. What are the disablers when it comes to showing commitment? So we want an environment whereby management does not put profit before safety, right? There has to be a balance. In as much as organizations exist to make profit, we want to do so in the safe way. So we don't want to see instances whereby management, they, want to proceed with operations at all costs, regardless of what the safety status is. And also, if we see management preaching positive safety culture, but we don't see the support in terms of the policies and the processes in place, that means it's a talk without action. Therefore, we want to see that commitment through the provision of those processes and procedures. The second safety culture value that I want to talk about is trust. Personally, I believe that trust is the foundation of a positive safety culture. We want an environment whereby there is trust that if I make mistakes, I'll be treated fairly, right? So that environment of trust enables people to come forward to report issues, right? So if you're not trusted, or if you have a punitive environment, the punitive environment creates that lack of trust. And people don't trust that they'll be treated fairly when they come forward. So we want an environment whereby people feel free to come forward. People should feel free to say, I made a mistake. What can we learn from the mistake that has been? It could be that the mistake or the accident or the incident that has happened is a systematic issue. It's not necessarily an individual issue. But if we are in an environment whereby there's no trust, people will be reluctant to come forward. And if people don't come forward, it's an opportunity that is lost when it comes to learning. Because if people don't report, if people don't trust the system enough to report, that will be an opportunity lost when it comes to learning from the organization. So what are the enablers of environment that fosters trust? First and foremost, we want an environment whereby there's clear distinction when it comes to acceptable behavior and not acceptable behavior. How will we know that? We will know that if we have processes and procedures. Remember, if you link that to the commitment, whereby we say organizations should have processes and procedures, they will support. It will be documented in terms of what are the acceptable behaviors, what are the behaviors that are not acceptable. Secondly, an enabling behavior, if there is an occurrence that has been reported, whether it could be an accident or an incident, in the first instance, we want to investigate the systematic issues or the organizational issues rather than going for a person. Because if we go for a person first, imagine the person will not come forward to report in the future. So in the first instance, let's assume that there's a systematic issue. Then we begin our investigation from there. I think if we have that environment, then people will feel free to come forward to report issues. The third one, we want to reward good behavior, right? We want to recognize it, right? We want to publicize it, right? So if we create that environment, I think we would build that environment of trust that ensures that we have a positive safety culture. Now, what are the disablers? So the disablers is those things that we don't want in our environment. For an example, the first disabler would be our organization is sort of vague in terms of what is good, what is bad, and what will create that, the lack of procedures, right? The lack of policies, right? The lack of documentation in terms of what is good, what is acceptable, what is not acceptable. And in that environment, you find that there's favoritism, right? Person A is not treated the same as person B, right? So that creates a lack of trust. And also, when we investigate, we don't focus on the individual, we focus on systematic issues. So the person will be, in the first instance, we want to do right? So if an accident happens, let's not assume that the pilot is wrong. Let's assume that there is a systematic issue. So that we don't want to go for an individual, we want to go for the system first and see how can we improve. The third one, if good behavior is not rewarded, that is a disabling environment. So we don't want that instance whereby good work goes without being noticed. The third safety culture value that we want to address is adaptability, right? We learn, we improve, right? And all of this is linked to the reporting. If people don't report, we don't learn. If we don't learn, we don't improve, right? So what are the key enablers of adaptability, right? So we want to create an environment whereby employees are actually encouraged to come forward to address safety issues, meaning that there should be a platform for people to actually address safety issues. When I talk about a platform, I'm not only talking about a reporting system, right? It means that we need to create other engagements, we need to create other platforms where employees or where people, especially the technical staff, can feel freely to come forward and talk about issues that can be improved in the organization without feeling attacked, which links to trust. If they trust you, they will talk. If they talk, you will learn. If you learn, you adapt. And we want instances whereby if there has been an incident or an accident that has been reported, we don't want to hide the findings, right? We want to know what has actually happened. And when I talk about what happened, we don't only want to address the symptoms, but we want to go to the root cause. And how do we get to the root cause? We also involve the people who were involved in the occurrence when it comes to the investigations. We don't leave them out. So it talks to transparency as well, because there are some things that you may learn that are not necessarily in the report. But if you have that environment whereby you investigate the root cause and you involved as many parties as possible in that investigation so that you can see how can you learn, adapt, and improve. When it comes to the processes and procedures that we have, how often do we question the processes and the procedures that we have? If are they actually serving us, right? So meaning that we must be self-critical. We must go back to our processes, policies and procedures to interrogate them whether are they still serving us. If not, we learn, we adapt, we improve. So that is the environment that we want to create. Those are the behaviors that we want to adopt. And what are the disablers when it comes to adaptability? The first disabler is that you eliminate people when it comes to discussing important issues, right? There's a boardroom with a reserved people where safety issues are discussed, and we don't want that. We want to involve everyone when it comes to discussing safety issues. You never know where the next big suggestion may come from when it comes to safety improvement. And also, we want to be proactive when it comes to safety improvement. We don't want to only act after an accident has happened, right? So we want to be proactive in terms of what is it that we can do better so that we can learn, adapt, and improve. Also, we shouldn't be complacent. We shouldn't wait for CAA to say we're changing procedures before we actually review things, right? So we need to be proactive in terms of how we do things. So meaning that we shouldn't be reactive, but we should be the first ones to act, right? We shouldn't react, we should act, then we learn, we adapt, we improve. The next safety culture value that we want to talk about is awareness. Awareness talks to the extent whereby employees or organizations are aware in terms of what are the safety risks in their environment. So what are the enabling behaviors that we want to see when it comes to the value of awareness? We want an instance whereby we have an effective hazard identification system, right? So we want to look for hazard, we want to identify hazards so that we are aware. If we identify hazards, we're in a better position to do our risk assessment or our risk management activities. If we don't know what could harm us, we won't be able to do our risk assessment, or we won't be aware in terms of the hazards that we have in the organization. Therefore, another enabler, we need to stay abreast when it comes to the improvements or the developments in our respective fields so that we can act or adopt or adapt accordingly so that we are not left behind. So what is it that we don't want to see when it comes to awareness or the lack of awareness, right? So if there is no effort that is spent in terms of hazard identification, that is the enemy of awareness, because if we don't identify hazards, we won't know what could harm us. And if we don't know what could harm us, we are depriving ourselves that opportunity to learn. Also, if we don't stay abreast, we are blatant, we say everything is good, we've been running this way, everything is good. We don't want to know what is happening out there. I think that constitute a lack of awareness. And lack of awareness, you may find that our processes are obsolete or the systems that we use are obsolete. Therefore, it also goes back to the issue of proactiveness in terms of knowing what is happening around us. So it's very important that we evaluate ourselves as the organizations to see, are we staying abreast in terms of the latest developments? Do we know what could harm us? Are people around us aware in terms of what are the safety issues? I'll make an example. If I were to ask, what are the top 5 risks in your organization? Will you be able to answer that? Right? If you can answer that, that to me signifies the lack of awareness. So you should be aware in terms of your operational context to say, if I'm an aerodrome, the top 5 hazards or the top 5 risks are XYZ. If I'm in the operations environment, I need to be aware so that I can take the appropriate action to make sure that we are all safe. The 5th safety culture value that we want to talk about is behavior. I think behavior talks more about an individual than an organization itself, because it's about how do I behave? What are the actions that I take? What motivates me to take the right action, especially when no one is watching, as the Just Culture definition would say, to define just culture as what people do when no one is watching. So how do we behave? What is our attitudes when we are faced with decisions where we have to make decisions to be safe? So what are the enablers when it comes to behavior? We want instances whereby employees actually motivate themselves to take the right decisions, right? Your manager is not there, CAA is not there. How do you motivate yourself to actually take the right decision? So we want to ensure that we continuously practice the right behaviors. We shy away from unsafe behaviors. We shy away from taking shortcuts, especially if no one is watching. Therefore, we must ensure that especially in the general aviation environment, because it is regulated, but in most instances you are alone. You have to make decisions alone. So when you make a decision, think first, think before you act in terms of the decision that I'm making, is it a safe one or not, right? So that's what behavior talks about. And what are the disablers when it comes to behavior? We don't want instances whereby employees or people are not punished for unacceptable behaviors, right? And when I talk about that, remember we have our policies and procedures, the framework in terms of the acceptable and unacceptable behaviors, right? Therefore, remember Just Culture, we want you to take actions that are commensurate with your level of experience, right? And the level of your training, right? At the same time, we don't want to create an environment whereby people get away with things, right? If there's a total disregard of regulation, such behavior should be dealt with or should be acted upon within the prescripts or within the frameworks that would have been established when it comes to the commitment to safety. And also, we don't want instances whereby we don't take constructive criticism, right? So we want an environment whereby if I'm wrong, if there's an opportunity to improve, I should be open to criticism. I should be open to accepting the opportunity also to improve, right? So we want to make sure that in the first instance, we have the right environment, the conducive environment whereby safety is, we put safety first in everything that we do. So last but not least, the safety culture value that we want to talk about is information, right? Which is the lifeblood of your safety management activities. So what does it mean? It means that information should be shared throughout all the levels of organization, right? So people should be informed. There should be appropriate channels. We want to create platforms whereby we engage, we share, we collect feedback from all levels in the organization. So what are the enabling environment or the enabling behaviors for us to have to live that safety culture value. We want to create an environment whereby there is open and just reporting system that is supported by all the policies and procedures. Importantly, the protection of information. And also importantly, the existence of anonymous reporting, right? It could be that our safety culture is not at the required level. People are still shy in terms of coming forward. Therefore, in terms of information sharing, you need to create that platform whereby people can report anonymously. Also, we want to have an environment whereby employees are provided with information, the right information on time. And this should happen throughout all the levels of organization, right? Why is this important? It's important so that people can make the right decisions, especially in the interest of safety. Importantly, again, we need to go back and review whether the information that we share or the channels that we use to share safety information, are they actually effective, right? Remember, communication is not one way. Communication is two-way. Are we getting feedback? Are we evaluating the channels that we have just to make sure that we are sharing information effectively, information is reaching the right people at the right time, and it enables them to make the right decision. Importance of knowledge transfer or knowledge sharing or training, right? That is another platform or another way in which we can share information. Importantly, we need to create that environment that facilitates that, and also we need to create the forums that actually facilitate. We cannot say in our policy, we cannot say that we promote the sharing and exchange of information, but we don't actually have the initiatives that actually facilitate that action. So we have to make sure that we have the right platforms, the right initiatives to actually share information. What are the disablers? Blame culture, right? We blame the messenger, right? So we want to shy away from instances whereby we blame, there's a blame culture, we're blaming each other when it comes to the reporting. Whatever has been reported, you'll be, ostracized in terms of why did you report it, right? Why does CAA know about this, right? So we don't want instances whereby we sweep things under the carpet. And it all starts from the top. If your management will tell you not to tell CAA, then you must know that there's a problem in terms of the culture. Even as an individual, if you find yourself in an instance whereby you say, oh no, CAA better not know about this, all right, what culture value are you promoting, right? So we want that instance whereby we want to come forward. Because remember, we said the sharing of information also facilitates learning. If we don't know about it, then we cannot, we are missing the opportunity to learn. So safety communication, if it's not monitored for effectiveness, we might as well be talking to ourselves. So we want to evaluate our information sharing platforms just to make sure that they are effective and they are reaching the right people. And if your organization, there's no training or training is not prioritized, therefore that means that we are probably not living up to the culture value when it comes to information sharing. So it goes beyond having a training program, but do you actually give people time? Do you actually take time to go and attend training to empower yourself so that you can learn, adapt, and improve? So in total, we have explored the 6 safety culture values, and we have outlined what each culture value stands for. We have also discussed in terms of what are the enablers and also the disablers. I know in my presentation I may have referred a lot to the commercial environment or the formalized environment, but as I've mentioned, as an individual, just ask yourself, how am I living the safety culture values, right? Because we said the 3 ingredients when it comes to the safety culture value is the policies, the processes, the procedures, but we have the people, the individuals when it comes to the behavior, and also we have people when it comes to the actions and the attitudes and our actions. So if we bring it all together, we are all impacted. I mean, safety culture cannot live in the vacuum. We are the ones who are living the safety culture values. So ask yourself, how am I living the safety culture value? What are the decisions that I'm making that are making me safe? And also my fellow aviators in terms of promoting aviation safety in all contexts, be it general aviation or commercial environment. I think we can all take specific actions in entrenching or living the safety culture values. So in conclusion, what are we saying? We're saying let's be safety conscious, all of us. Let's adopt the right behaviors to be safe, the right behaviors to promote aviation safety. Let's create an environment that fosters a positive safety culture, that fosters a just culture. Let's promote the safety culture values, not only amongst ourselves or within ourselves, but let's get the conversations going, right? Let's get the engagements going. Let's discuss with our fellow colleagues, our fellow aviators in terms of how can we internalize the safety culture values and how can we live the safety culture values. The CA has resources to assist you in terms of the promotion of a positive safety culture or the entrenchment of a positive safety culture. So we invite you to reach out to us to get more information or to get resources in terms of how can you evaluate a safety culture and also what are the initiatives that you can implement to promote a positive safety culture. Thank you, Mr. Chair. I think I will end here.
We now joined by Bongi, and this is your opportunity to ask questions, and Bongi will respond to your questions. So please feel free to use the platform on Zoom to send your questions, and I will be able to receive them here and pose these to Bongi. Bongi, thank you for your presentation. You've spoken quite substantially on aviation culture in a more corporate and formalized environment, such as airlines and corporate aviation. But please tell us the key components, in your view, of a positive safety culture in the more informal sector. This is the GA sector. What would those components be in your view?
Thank you very much. That's a very good question. I agree the general aviation environment is less structured and less formalized. However, safety culture still applies. So I'll just talk about 4 key components or key factors that can be implemented in general aviation environment. The first one is risk awareness, right? So general aviation pilots have to be aware of the risk that's associated with their operating environment. For an example, they need to know the aircraft limitation, human error, and they need to know about the weather. So that is a factor. The second factor that I will talk about is open communication and reporting, right? So an environment whereby there's open communication will encourage reporting of incidents, accidents, and near misses. And it is through this reporting whereby we can learn more about risks and also implement measures where we can avoid them. The third factor that I will focus on when it comes to general aviation is safety-oriented decision-making. So general aviation pilots need to make safety-oriented decision-making based on the available information. So they shouldn't take chances, they shouldn't also take shortcuts, they shouldn't be complacent. The last one that I will focus on is peer support. That is very important to encourage that positive environment where they can all encourage each other to adopt the right behaviors, which speaks to a positive safety culture.
So Bongi, as a follow-up, we understand you speak about peer support, and there's also this concept called just culture. And we have a question here, and the question is on operators or companies that would threaten their employees when the employees report safety issues with the hope that these safety issues would rather be addressed than cause an accident. Can you give us your comment on that?
Yes, definitely. If you punish your employees because they're coming forward, you are literally shooting yourself in the foot, right? So the behavior that you're encouraging is to hide things, right? If there's no reporting, there's no learning, right? So I always say, if something is not reported, that's a missed opportunity in terms of learning. So if employees are coming forward, they're actually helping you, they're helping themselves to be safe. So I would say that adopt the just culture principle, do thorough investigation to find out what went wrong. Don't go for the pilot. I think I've mentioned that. Look into the whole system. So to me, reporting is an opportunity to learn. So I think we are driving this culture whereby we don't see it in a negative light, but in a positive light, so that we can all learn, adapt, improve, and be safe.
Bongi, so there is this misconception at times that safety does result in a business which is not profitable. It eats away at profits, and therefore one believes that they should save costs as a result in the safety space. Please give us your thoughts on such a mindset.
Thank you very much. If you think that safety is expensive, then try an accident. Then you will see that safety is actually not expensive. If you have, I'll go back, I'm a safety management systems person. If you have your systems properly implemented, they will actually run safety for you. All right, so there will be no need for you to cut profits. And of course, business exists to make money, but we're saying do so in a safe manner. And there has to be a balance. So you can't keep on cutting corners. And as I've said, that if you think that you cut corners and cut and make more profit in the undercutting safety, then try an accident, then you will realize that it's the biggest mistake you will make.
Well, we thank you, Bongi. That was our final question for you. Thank you. So to the audience, next up is, for the evening, is Mr. Dave Gove. And Mr. Dave Gove will be talking to us about extreme flying accidents and also identifying the 12 classic accident pitfalls. We'll thereafter follow with the Q&A.
Welcome to the South African General Aviation Accident Reduction Seminar. My name is Dave Gove, and I'm an inspector for the General Aviation Department of the Civil Aviation Authority. We are going to look at various elements of safety-related issues, and we specifically at the GARS are going to look at extreme flying accidents. Okay, so the outline of this presentation today is that we are going to look at the extreme flying accidents. The objective is to cover things like the 12 classic accident pitfalls. We've also got an accident scenario that we have retrieved from the CAA, which anyone can, and we'll have a conclusion regarding to the classic accident pitfalls. We're expecting this duration of the presentation to be approximately half an hour. All right, let's look at classic pitfall number 1. And this is responding to peer pressure. So this is poor decision making, emotional responses to peers, rather than to evaluating the situation objectively. All right, a classic pitfall number 2 is mental expectancy. The inability to recognize and cope with changes in the situation different than that anticipated or planned. Visual illusions and similar aural sounds occurring at the wrong time often lead to such miscues. Okay, classic pitfall number 3 is get-there-lighters. This is a disease common among pilots. It clouds the vision and imparts a judgment by causing a fixation on the original goal or destination combined while with a total disregard to any alternative course of action. Right, classic pitfall number 4. This is duck under syndrome. So this is a tendency for the pilots to sneak or try and have a sneak peek by descending below the minimum during an approach, based on the belief that there's always a built-up fudge factor that may be used, or an unwillingness to admit defeat and to shoot a missed approach. Classic pitfall number 5, scud running. This is pushing the capabilities of the pilot and the aircraft to the limits by trying to maintain visual contact with the terrain while trying to avoid physical contact with it. Right, classic pitfall number 6. This is continuing VFR into IMC. The all too often result of the practice of scud running when it becomes only an alternative to flying into the ground. It is even more dangerous if the pilot is not instrument qualified or is willing to believe what the instruments are actually indicating. Classic pitfall number 7. This is getting behind your aircraft. Allowing events or the situation to control your actions rather than the other way around. This is characterized by a constant state of surprise and what happens next. Classic pitfall number 8, and this is loss of positional and situational awareness. In the case of getting behind the aircraft, which results in not knowing where you are and the inability to recognize a deteriorating circumstance and or the misjudgment of the rate of deterioration. Well, classic pitfall number 9. This is operating without sufficient fuel. Ignoring the minimum fuel reserve requirements under either the visual flight rules or the instrument flight rules is generally the result of overconfidence and lack of flight planning or deliberately ignoring the regulations. Classic pitfall number 10, descent below minimum en route altitude. So this is what we could call a duck under syndrome, as mentioned earlier, and manifesting itself during the en route period of the IFR operation. Classic pitfall 11, flying outside the envelope. So unjustified reliance on the usually mistaken belief that the aircraft's high performance capabilities meet the demands imposed by the pilot's usually overestimated high performance flying skills. Classic pitfall number 12, neglect of flight planning, checklists, pre-flights, etc. Unjustified reliance on the pilot's usually overestimated short and long-term memory of a regular flying skills or repetitive and familiar routes, etc. Okay, so what we have in this slide is the summary of the classic pitfalls, all 12 of them. So kindly note those 12 pitfalls because we're going to revisit this list shortly. Okay, let's move on to our scenario. The accident scenario can be found on the CA website, and the accident report name is the CA 18-2-3-8017. Okay, so this is a section taken out of the accident report. So we have the details of the report, which we also call the executive summary. We've got the registration of the aircraft indicated here, and all of the relevant factors, the time of accident, the age of the pilots, how many occupants were on board, the coordinates of where the aircraft had its accident. But let's go into more detail with the next slide. All right, let's look at the synopsis. We have a map of the departure point being George to this particular road where there was a vehicle accident. And this is an emergency medical flight to pick up the casualty. The distance was 45.2 nautical miles, which took the pilot approximately 25 minutes to arrive on the scene. So on the 2nd of October at 16:15, a helicopter was dispatched from George with a pilot, 2 paramedics on board to attend to a serious road accident near Haarlem on the Lange Road. the helicopter landed on the road, and the road accident site was approximately at 1640. All right, the helicopter was on the road accident site for approximately 1 hour. 10 minutes before taking off, this is known as scene time. This could be due to the stabilization of the patient. And in this slide, we can see that paramedics use this priority group table that will determine is this patient fit to fly, or is an ambulance sufficient, or even worse, is the patient possibly on their last? Okay, here's a photograph from another helicopter that shows you a little lightning, a little arrow there pointing at the road. And that's the scene where the helicopter in question of this accident was located initially before returning back to George. Okay, so as you can see now, there is a dotted line on the map, and that dotted line represents where the pilot, where he flew from George to the site. Now, you'll see that he got airborne, and he covered a total distance from the takeoff point with the patient on board until impacting the mountain, which was only 4 nautical miles away. However, the time of liftoff from the accident site, the vehicle accident site that is, to collect the casualty, until the aircraft impact zone, the time was 40 minutes, which is rather peculiar. So at approximately 17:05 Zulu, it took off with 1 patient who was seriously injured, and for the flight back to a hospital in George. So at 18:30, the helicopter crashed in the mountains and the terrain near Haarlem. All the occupants perished and the helicopter was destroyed. As we can see in this picture, there with the red arrow, we have the position of where the helicopter impacted the mountain. The crash investigators took some photographs, and you can see that the helicopter was completely destroyed. And that's a piece of the tail boom that is left over there. All right, so let's go and look into this report a little bit more closely. So the name, owner of the operator was the Air Ambulance Service, or Red Cross. Okay, the manufacturer of the aircraft was the Messerschmitt Balco. The model, as we can see written over there, it's part of the BO105 series. This was the S model. Nationality South African. Registration marks were Zulu Sierra Romeo Mike Romeo. The place is near Haarlem. 2nd of October 2005 is the date. It happened at 18:30 Zulu. Let's just take note of that time. Keep that in mind. Right, the pilot in command was a South African national, male, 35 years old. He had a valid license. His endorsements for instructor, instrument, test pilot, and night ratings were valid, as you can see on the list, and his medical expiry was still valid. It was valid until the 31st of October 2005. He had no restrictions and he had no previous accidents. His total flying experience was 1,779.7. The total time he flew in the past 90 days, and audience, please notice this, was only 4.6 hours. The total on that particular type, the BO105, in the last 90 days was also only 4.6. So the total time he had on that type of aircraft was 4.6 hours, which I think is a bit low. The meteorological conditions, the wind direction was 180 degrees. The speed was approximately 5 knots. Visibility was unknown at that particular area of the accident. The cloud cover was unknown. The temperature was 10 degrees Celsius. Dew point was at 8 degrees Celsius. So we can see we don't have a very big spread between the dew point and temperature, which means that there could have been a rather bad visibility. The next thing I want to bring into the equation is the moon state on the 2nd of October 2005. As you can see, it was falling more into the new moon, or the moon state. Its illumination was only 1.1%. So if the visibility due to visible moisture or cloud was part of the factor, and you have a moon state of 1.1%, that is a very, very, very dark night. Aids to navigation. Well, let's see, the aircraft was equipped with standard navigational equipment for that aircraft type. At the time of the accident, there was no communication with the air traffic control at George, and I assume that's because of line of sight and due to the valley and the mountain ranges surrounding the pilot at the time. And there was no transponder squawk number given or was observed. All right, the helicopter crashed in possibly cloudy night conditions in mountainous terrain, fatally injuring all the occupants. The pilot held a valid commercial license with a night rating, an instrument rating, and a grade 3 instructor's rating. The pilot held a valid unrestricted medical, which it was valid until the 12th of January 2006. He was correctly licensed to conduct the flight, although he had limited experience on that particular aircraft type. And of course, the result was the aircraft was destroyed during that impact and ensuing fire. Right, probable causes, let's have a look. CFIT, absolutely, I would say, controlled flight into terrain. The contributing factors would be nighttime flight, spatial disorientation, and poor weather conditions. Okay, so what we're going to do is we're going to look at the 12 classic pitfalls, and we're going to tie this together with this accident scenario of the EBO 105. Okay, so was the responding to peer pressure, mental expectancy, or get-there-litis? Let's have a look and see. This could have been a causal factor. I have no evidence is there to really support this. So we don't know what the culture was at the company. If he was forced, we'll never really know that at this stage. Okay, so duck under syndrome and scud running. This may not have been relevant in the unfolding events of this accident based on the accident report. Continuing VFR into IMC, getting behind the aircraft, loss of positional situational awareness. Well, this may have been a major contributing factor as it was a moonless night, or almost moonless, with a temperature and dew point spread of only 3 degrees Celsius, possibly resulting in the formation of cloud that could have led up to a loss of situational awareness. Okay, operating without sufficient fuel, descending below the effective en route altitude. This did not seem to be a contributing factor according to the accident report. All right, flying outside the aircraft envelope, neglect of flight planning checks and pre-flights. This could have been a causal factor, however, no evidence is available to support this point. I now have a short video, a safety video to share with all of you. I think it's very relative to this presentation. And I would just like to thank all the audience for joining us to watch the guys. Thank you so much.
You're looking at the weather and it's legal for now. But the day's forecast calls for worsening conditions that might go below limits. Your flight today is for an important new customer that needs parts delivered 50 miles away. You rush through your weather and pre-flight and realize you'll be cutting it close with the forecast. You're informed that the parts are delayed in reaching you, and the weather isn't getting any better. You hurry through your checklists, but you got this. The weather's coming in faster than you thought, but just swing around it. If you canceled every time it looked like this, you'd never fly in this region. As visibility continues to drop, something just doesn't feel right. You gotta stay clear of clouds in this airspace.
Obstacle. Caution.
What's the height of that new transmission tower around here? Okay, this is getting sporty, and those clouds are a lot thicker.
Warning.
You are way too low. And now, you've just punched in. You feel paralyzed. Time is standing still. You vowed never to let this happen. You now have 56 seconds to live. You're way too low, and it's like the ground is reaching up to you. Panicked, you overcorrect. In no time, you're climbing fast. You now have 45 seconds to live. Now you feel like you're turning and tumbling all at the same time and have lost faith in your instruments.
Warning. Terrain.
You now have 30 seconds to live.
Warning. Terrain.
This has become a nightmare roller coaster ride.
Terrain.
The aircraft is screaming for your attention, but a part of you is starting to let go. Everything's darker now. You think of your family one last time. I'm sorry. Can you forgive me? But they can't hear you. Because you are out of time.
Terrain.
So we have the final opportunity at this point for questions and answers. So please continue to keep your questions coming in. And this is our final presentation for this evening. And thereafter we will close tonight's event. Dave, it's pretty late right now. And we know microsleep is a real thing, specifically in aviation. And it can cause untold issues with regard to the safety of a flight. What is microsleep caused by?
Well, it's fatigue related. So if you haven't had a good rest, maybe your flight and duty periods are wrong. That could have a causal factor on a microsleep. Literally, microsleep is where you're in flight and you actually fall asleep for like a split second or two, or a second, give or take. And it's literally sleepwalking in that state. So that's what that issue actually is.
Sleepwalking, essentially, yes.
Yeah.
And that's a real thing, of course. So please tell us, with regard to LOCI, or loss of control in flight, what is the most common causal factors of loss of control in flight?
Well, based on this previous video, I would say the main causal factor is somebody who's not instrument rated, doesn't have instrument experience, inadvertently flies into instrument meteorological conditions. And eventually they don't trust the instruments and they end up in what they call a graveyard spiral as they lose control.
And finally, Dave, we speak about pilots becoming disorientated in flight with no visual references. Why does this happen?
It's to do with inside our ears, we have semicircular canals. And they have fluids that move around in them. And it helps us with our orientation. It helps us also with our balance. And cued into with us is our eyes as well. So with the two of those sensory components, we are able to know if we're moving or what position we are. If we're orientated, even in water upside down, you'll know you're upside down, okay? The problem is once you lose your visual connection, those fluids will still continue to move around, especially if you're in cloud, in turbulence, or doing specific changes in direction or acceleration, and it will give you what you call vertigo. So it will feel like the aircraft is consistently, say, rolling or pitching, when in the meantime it isn't. It's actually the vertigo that's causing that sensation, which is not true. If you look at your instruments, you've got to trust your instruments.
And it's true to say that many accidents have been caused as a result.
Absolutely, absolutely.
Indeed. So thank you, Dave, for
You're
your
welcome.
presentation as well as your responses to the questions. With that being said, this was our final presentation for this evening, the General Aviation Accident Reduction Seminar. Thank you for being part of this event with us. Again, the purpose of this event is really for yourselves as aviators to make sure that when you take to the skies, you're more richly endowed with safety information, and the CAA continues to exist to provide a safe flying environment for all aviators. And I hope that you enjoyed today's evening. Thank you all for joining, and we look forward to the next event. Goodbye.